What a sight! NASA's Mega Moon rocket is on the launch pad after recently completing a wet rest.
Uy, encima que estaba esforzando la voz, tenía el micrófono muteado, no puedo creerlo. Bueno, parece una broma. El lanzamiento de hoy va a ser increíble, porque aparte del lanzamiento, van a ser 6 días de una danza de esa nave alrededor de la Luna para poder inyectarla en esa trayectoria tan increíble que van a mantener. Es algo que va a ser realmente histórico. No podemos perderla. Muchísimas gracias a todos por ese apoyo enorme, por seguir apoyándome. Un abrazo. Voy a tratar de hablar algo igual, porque no me aguanto.
4:55 UTC. In Eastern Daylight Time, that translates to 5:55 in the morning for you, Daryl. Sorry about that. And for Pacific Daylight Time, liftoff is scheduled to a even unfriendlier 2:55 a.m. Our latest status update from our weather official in Mission Control reported clear skies over the launch site. The weather is nice and still this evening, with the probability of violation very low, meaning we are very close to that launch liftoff. Now, over the past few hours, Rocket Lab's launch crew on the ground and in mission and range controls have been readying the launch pad with vertical and avionics checks with the rocket, and have loaded Electron with its propellant types, kerosene and liquid oxygen. So right now, with just about 50 minutes left to lift off, all systems are go for launch, and I'm going to hand it back over to you at Kennedy, Daryl.
All right, great report, Muriel. And quick question for you. Why launch from New Zealand?
Daryl, if you're looking for a launch site anywhere in the world, the ideal location is an island in the middle of the ocean, which New Zealand as a country makes a great option for. And if you're going to launch east, which you would like to do because you get that free push in the same rotation of the Earth, then the east coast of New Zealand is a great place to be, and Mahia on its peninsula jutting out over into the coast is a wonderful spot because we have very little air and marine traffic. So it's really a one in a million location.
It certainly is, and it's incredibly gorgeous, especially during the daytime, and hopefully in the future we can show you a daytime launch as well. Well, we've got a lot of cool stuff to show you coming up in our pre-launch show, as well as some great interviews. First, we'll take a closer look at the CAPSTONE mission itself, the very first spacecraft to fly.
Sigue susurrando. No sé si así se entiende y se escribe. Si se entiende lo que digo susurrando. El esfuerzo es cero. Pero me parece que es una locura esto de hablar susurrando.
NASA astronauts will dock before going down to the surface of the moon. After liftoff, it will take about 4 months for CAPSTONE to get into the near rectilínea.
4 meses le lleva finalizar. La misión esta son 2 años de demostración.
Before NASA's Artemis astronauts go to the moon, a small spacecraft called CAPSTONE will help lead the way. The Cislunar Autonomous Positioning System, Technology Operations and Navigation Experiment will test a unique lunar orbit that has never been flown before.
Nunca se voló una órbita de este tipo. Se entiende perfecto. Se escucha piola. Sí, entonces, qué increíble. Qué increíble, bueno. Esto es cero esfuerzo, la verdad.
Rocket Lab will launch the spacecraft.
Esta nave CAPSTONE, que en realidad es una sigla en inglés, que la sigla dice lo que va a ser una órbita, el tipo cislunar, alrededor de la luna, y la estamos viendo. Pesa 25 kilos, es como un microondas doméstico. Imagínense el horno que tenemos en la cocina, con 3 aletas de cada lado, que son los paneles que ahí se ven abiertos, que va a estar orbitando la luna en la misma órbita que va a estar la Gateway. Van a probarla. Hay una cosa, esa órbita nunca se probó, se calculó matemáticamente, y lo que van a hacer ahora es validar los datos matemáticos para poder corregir el día que manden la Gateway. Y va a ser un baile, porque colocarla en esa órbita es más difícil que colocarla en la órbita de Lagrange que vimos con el James Webb. Es re complicado, más para un cohete tan pequeño como el Electron. Y la segunda etapa, la Photon. Otra de las cosas que va a hacer CAPSTONE es comunicarse con el orbitador lunar, que ya hace años que está dando vuelta a la luna con otra órbita distinta. Ahora, ¿para qué se va a comunicar con el orbiter? Porque entre los dos, como ya se sabe dónde están, calculan la distancia y calculan su posición. Entonces van a crear un sistema de posicionamiento global lunar, una especie de GPS de la luna. ¿No? Es alucinante. Nuevo esfuerzo. No es esfuerzo ninguno. Miguelito, sirven. Un abrazo. Un abrazo a todos. Voy a aprovechar a leer un poquito. Antonio fue el primero que apareció, David Sabaman. Martín con su ritual increíble. Miguel Ángel de Gustavo Weidler, Gustavo, qué temprano. Manuel. Rosa Sierra. Yo mismo se llama, no soy yo. Son de fierro, como decimos acá, o sea, son de acero, están siempre. Un abrazo enorme, en serio. Son las 6 de la mañana en Uruguay, acá en Sudamérica. Madrugada, en serio, ¿no? Ahora después digo cuánto dormí. En realidad me desperté solo. Esta misión es re excitante. Yo no puedo creer. Voy a criticar a un youtuber. Scott Manley, para mí es uno de los mejores. Puso en Twitter, en Rocket Lab, que era muy temprano, que eran como las 6 de la mañana para él, que no se iba a levantar. Yo no puedo creerlo. No puedo creer que alguien no se levante a ver esto. Sinceramente, a quien que le gusta el espacio, un primer lanzamiento lunar, la primera misión de Artemis. En realidad, esta es la primera misión de Artemis. Que no vayan a verla, no me entra en la cabeza. Ya estoy bajando volumen también, que estaba saturándose. Mil disculpas. Inclusive bajé ahora la música de fondo para que ayude un poquito más. Bueno, ahí tenemos el equipo de Advance. También estuvo trabajando ahí. Esta es otra de las empresas. Hace 2 años que Rocket Lab, NASA y este equipo de Advance Space están trabajando sin descanso en esta misión. Esto no es mandar un cohete a la luna solamente. O sea, si mandas un cohete a la luna, como se dice, le pegas a la luna. Vamos a ver cómo lo hace.
A low fuel requirement to get this satellite, which only has so much fuel, into that orbit, has to be a gateway, just like NASA's doing. And then NASA in general has tested out a lot of different orbits. We've landed on this NRHO because of its terrific viability.
And with this spacecraft here, when it maneuvers, it's these small little jets here at the bottom. Is that right?
Yep. That's right. Yeah, it has enough fuel to do everything we need. We have enough fuel for an extended mission as well. It's a monopropellant hydrazine system.
Es increíble la descripción de cómo es el alcance de la órbita.
Yeah, another spacecraft. That's right. Our spacecraft has 2 radios, one to talk to the Earth, which is a conventional approach, and one to talk to another spacecraft, the LRO. And this is a reverse radio for LRO, so it's perfect to talk to LRO. We're going to demonstrate navigation in a couple of ways. One with communications with LRO, which should be enough to navigate the spacecraft.
Juan Canova de Turia, muchísimas gracias.
Which is a future advanced navigation technology. Everything we can
Sigo en deuda porque les prometí el domingo un video que estoy haciendo de actualizando mi situación médica. Lo voy a hacer, lo voy a terminar. Estoy realmente en deuda. Le cuento, estoy esperando los resultados de los análisis de lo que se llama la anatomía patológica. ¿Qué es eso? Bueno, me quitaron un bocio, o sea, la glándula tiroides, donde tengo un problema. Recién, en 2 días más o 3, están los resultados. Esos resultados van a dar cuál va a ser el tratamiento que tengo que seguir, que me van a poner para poder seguir adelante. Creo que tengo mucha fe. Hay muchísima gente, ustedes, muchísimos, que están también apoyándome. Así que vamos a verlo y vamos a seguir teniendo fe en que todo va a estar bárbaro.
our IT support engineer. Across the aisle is our senior launch conductor supporting the flight director based out of mission control.
Tenemos una imagen distinta del centro de control, ¿no? De menos 40 minutos.
And its reaction control systems. Their cool names are prop and stage. So in front of them sit the engineers.
Está mejor mi volumen ahí. Se escucha, se entiende lo que digo, ¿no?
And monitoring the state of the rocket's flight computers.
Martín, un abrazo. Guatemala, 3:15 de la mañana. Nos vemos, gracias.
Who monitor the launch pad's ground systems. And to their left, on the right of your screen, closest to the camera, are the avionics operators with eyes on the operator.
Está describiendo las posiciones de cada uno de los que están allí en la sala de centro de control. No veo a Peter Beck.
Launch safety officers keeping a close watch on the launch pad's surroundings.
Peter Beck es el dueño de la compañía.
To mission control here on your screen, this hub is in Auckland.
Claro, esto es Auckland.
Photon and Lunar upper stage.
Son distintos sitios. Peter generalmente se sienta acá atrás. Puede ser, es posible que este sea Peter.
Engineering support for the flight software on the Photon Lunar upper stage. In the middle of the row to the end,
No lo
the
distingo.
engineers managing ground tracking for today's launch. And then on the end is our operator with eyes on Photon's hypercurie engine. Behind them,
Se la fe,
closest to the camera,
mueve montañas. Les agradezco toda la fe que puedan tener.
engineers
Todo
who
lo
are
mucho
across
que
Photon and
Sí.
CAPSTONE's path to the moon. Their call name is Fido. In the middle sits the spacecraft engineer supporting Photon's communication software, and on the end sits Space Ops software ensuring our telemetry makes it from the Photon spacecraft to the operator. Now moving to the back row, starting from the right, sits our weather officer for today's mission, followed by the engineer managing the IT systems, linking range and mission controls, and then our team lead, responsible for our hardware simulation platform called COHETE, which we use to simulate multiple flights to orbit before each mission we launch. And next to them sits Tank, which monitors Photon's fluid systems to ensure its hypercurie engine is provided with its propellants. And finally, at the end of the row is our Director of GNC, Dr. Jonathan Curry. So with that, we are now at T-minus 38 minutes and counting, and proceeding comfortably with the countdown to liftoff. A quick reminder that launch today is set for 9:55 p.m. New Zealand time, or 9:55 a.m. UTC. Over to you, Daryl.
All right, thank you, Muriel. It'll be 5:55
Tenemos a
Eastern
Daryl,
time
así.
as well. Joining me now is Ali Guarneros Luna, project manager for NASA's Small Satellite Program. She's here to talk about why CubeSats like Capstone are proof that small satellites can have a big impact. Thanks for being here.
No, thank you for having me today.
So why would NASA choose a small satellite instead of a large one?
Well, I mean, the reason why we choose small satellites is to be able to understand the risk of the missions that we're trying to develop, and small satellites actually gives us the benefit of doing, taking bigger risk. And so having the small satellites being able to, utilize and develop the technology for the bigger missions like the Gateway,
Se me
is one
risa.
of the reasons why we choose the
Se
Capstone.
escucha fabuloso.
And so
No
what
puedo
are the
creerlo.
most important factors
No puedo
when you
creerlo.
design a small satellite?
Son fantásticos.
Well, definitely, I think it's going to be understanding the mission architecture, where you're going, understanding the
Hago un
requirements,
reset F5 un segundo.
and
Me parece que
trying to
podría llegar a estar
develop
laggando.
that technology so you can infuse it later into the bigger missions.
It's fascinating.
Capstone is going to be for the Gateway, and so that actually gives us a lot of benefits because we can turn around and really develop that and mature that technology.
Which will help the mission behind us right here,
Yeah.
which is
Yeah.
the SLS not launching today, but a beautiful shot on the pad. We've got
Yes.
two different rockets on two different pads in vastly different locations. On a more personal note, Ali, I was reading
Marina,
an article
muchísimas
about
gracias,
your
Marina.
personal journey here.
Muchas
It begins
gracias.
with an 8.0
Ni qué genial
magnitude
lograr el
Mexico
proyecto
City
simulacro
back in
con la luna.
1985.
Qué ilusión.
5,000
Se te escucha
people
perfecto.
devastated
Abrazo grande y
person
cuídenle esa
you were,
voz.
born and raised. Before you became
Mañana.
tell me a little about
Hoy
your
es
personal
martes,
journey
¿no?
and-
Estoy medio
and
perdido.
how that sparked
Sí, hoy es martes.
you and your mother's journey here in the United States.
Hoy hace,
Well,
maña-
definitely,
hoy hace
it's a
2 semanas y un
long story,
día
but just
que
to
me
make it
operaron.
short,
Mañana
when the
martes
earthquake happened,
empiezo
my
fonoaudiología.
had purchased
Se supone que eso también
before,
me va a ayudar a
and
recuperar
had
la
a
voz.
well
No sabemos
education,
todavía
so for her to
si la lesión
be
en la
able to
voz
survive,
es
in Mexico at the
anterior
time,
a la cirugía,
not
si es
viable.
posterior o es ambas. Tenemos que esperar todavía unos días más para hacer un nuevo estudio. Es horrible, una nueva laringoscopía. Te meten algo por la nariz así para ver las cuerdas vocales. La verdad, no se lo deseo a nadie, pero voy con muchas ganas de hacerlo. Mañana empiezo fonoaudiología con una familiar que es divina. Viene a casa. No puedo creerlo. Me tienen un apapachado que no puedo creerlo. David, muchas gracias, David. Sí, gracias. La energía de ustedes es increíble, la verdad.
Have them to have a better life, and for me going back to school was the drive, and so I did it and I graduated, and then when I was graduated, my professor actually told me there's an internship at NASA. I ended up working at NASA, not thinking that was the path that I was going to take, but I'm here and I'm really happy to be here.
How about that? What an inspiring story, Ali. Thank you for sharing it with us, overcoming all those hardships.
Voy a cambiar un poquito, voy a sacarme esta ropa.
Good luck on the launch, and thank you again for being here. Well, we've showed you how Capstone is a Pathfinder mission for NASA's Lunar Gateway. As NASA astronaut Randy Bresnik will show you, the planned orbiting lunar outpost is the first step to fulfilling plans for a more permanent presence on the moon.
Home. For me, home is where my family is. But there have been times in my life where I was called away from my family for extended periods of time. While I was serving in the Marine Corps, it was hard to be away from my loved ones. But thankfully I had my squadron family, but other places where we were stationed around the globe became a temporary home. Then, in 2009, I launched the International Space Station, traveling even farther away from my family, conducting science 250 miles above the Earth. The space station was an orbiting home for my crewmates and myself. Talk about a room with a breathtaking view.
Sí, Alejandro, muchas gracias por la atención, Alejandro.
And the first person of color to the moon. We are going there for the benefit of all here. We'll need a place to orbit around the moon, where we can live and work. A place to get ready for our lunar surface expeditions. And a place to return to when our work on the lunar surface is complete.
¿Qué me está contando? Surbuker, toma Surbuker. Qué divino esto me está contando.
Starting with the power and habitation modules, the gateway will be
me encanta.
the long-term outpost in lunar orbit humans have ever had.
Está contando lo que va a pasar con la Gateway. El nuevo laboratorio. Thomas Urbukin es el administrador asociado de ciencia de la NASA. Es un genio, es un genio. No es Thomas. Qué parecido.
Design and fabrication of gateway elements by NASA and our international partners is well underway around the world right now. Wherever you are on planet Earth, today you are part of the Artemis generation. I'm NASA astronaut Randy Bresnik. I invite you to join us by following
Randy Bresnik es un astronauta de NASA, pero qué parecido.
and telling us where you call home.
Esta de Caballe, vino de Caballe,
31 minutes and
vino de
counting until
Argentina.
launch in New Zealand with our NASA Mega Moon
Hace
rocket
un mes
here
estuve en
on
Buenos
the
Aires con la
ground.
familia paseando.
It's
Qué
time now
divina
to
ciudad.
dive into the details of Capstone's orbit, the near rectilinear halo orbit. I spoke to Jude Moranci, chief of the NASA Exploration
Asadito
Planning
radio.
Office, about it.
Buen día, dice haciendo SMR. Me lo sugirieron. Se escucha, se entiende, creo. Así que bueno, me encanta porque también puedo comunicarme así. Odio ese voto, odio. Esta tarde tengo una reunión con la gente de Google. A ver si podemos buscar alguna solución robótica usando las grabaciones de mi voz. No tengo mucha esperanza. Pero vamos a ver qué caso me hacen.
It takes to get somewhere and the time it takes. So Capstone is using a ballistic lunar transfer, so it'll take 3 months to get to NRHO, but it'll use a quarter of the Delta.
Javier Martínez, muchas gracias por los saludos, el apoyo. Capuchetti, gracias por estar.
5 to 10 days in transit. We'll fly very close to the moon and use
Gracias,
the moon
Pedro.
to slingshot us out there, but it takes more delta velocity or, relative propellant amount. So, we can play with both the time and the duration to get into NRHO based on whether we're flying crew or you're doing something so uncrewed like the CAPSTONE mission.
And looking at this near rectilinear halo orbit, you can see it really goes quickly around the moon.
¿Visto cómo
but
es
spends more
la
time away
órbita?
from
Es
it.
increíble
Why
la
is that,
órbita.
and are there advantages or disadvantages to that?
Yeah, so the NRHO or near rectilinear halo
Se-
orbit is
lo
in the
que se
low
preguntan, a
orbit.
ver si
So when
vamos
you're
un
close
poquito
to the
más.
moon,
Esto,
the
¿qué es lo que quiere decir CAPSTONE? Acá lo tenemos. Esto es CAPSTONE, cislunar, autónomo, posicionamiento, sistema, tecnología, operaciones, navegación, equipo. O sea, en realidad es equipo de navegación y operaciones, sistema de tecnología de posicionamiento autónomo a través de la Luna. Eso es lo que significa, se lee un poco medio como al revés. Eso es lo que significa CAPSTONE, es lo que van a hacer.
So that means we can put the gateway there for 10, 15 years and not need a lot of propellant to keep it there. But it's also close enough to the moon that the human landing system can access the South Pole. We can
Esta es una promo que habían hecho, que está muy buena.
as well as have that stability for a good outpost.
Esta es la trayectoria que va a ser
Really it was that
una trayectoria balística.
for the long-term planning of Artemis and
Entonces se empieza a agrandar lo que se llama el apogeo en cada una de sus órbitas. Hace una quemada para poder agrandar esa órbita. Entonces el Sol, Sol lo ayuda a cambiar la inclinación gratis. Y eso es el modelo, eso es lo que empieza a hacer. Y miren cómo empieza a modificarse para poder capturar a la Luna. Se aleja, vuelve y cae como si fuera una pelota de tenis. Es brutal el baile que va a hacer. Me entra en la cabeza. Wow, Juan. Muchísimas gracias, Juan, por la donación. Argenis Mejía dice saludo de Venezuela, 5:24 de la mañana, otro espacio trastornado, dijera mi amigo Isma. De temprano viendo tu directo, es un abrazo. Y para adelante, que va a salir bien de todo esto. Ulises Yayo, Daniel, mucha fuerza y ánimo desde Canarias, España, y muchas gracias por tu esfuerzo. No es un esfuerzo, primero, me apasiona. Esto me enloquece, no de ahora, hace de toda la vida. Descubrir que puedo compartir esto con ustedes es la cosa más increíble que me ha pasado en los últimos años, en serio. Entonces, ¿cómo no voy a compartirlo?
CAPSTONE is a pathfinder mission. CAPSTONE is going to be demonstrating how to put a space station at the moon.
So it's important for us to characterize.
Es impresionante esto. Los lanzamientos de cohetes son fabulosos. A mí me excitan, me emocionan muchísimo. La tecnología de la ciencia, la cotería, me parece increíble. Me he puesto a leer, a tratar de estudiar matemáticamente. Y me supera ampliamente la mecánica de las órbitas. La verdad, me hubiera gustado poder saber algo más también. Pero lo que están haciendo ahora con esto es realmente loco. Y lo más increíble es que Rocket Lab es una empresa chiquitita. Este cohete es una cañita voladora. El Electron que pone carga en órbita, sí. Es chiquititito, no existe. Tiene un futuro Rocket Lab que es brutal.
We can talk just directly with LRO and determine where we are in space, determine our position and our velocity in space.
You don't just know that you are, X kilometers separated. You can actually estimate the full six-dimensional state of both.
Aquellos que les guste esto, sí. Aquellos que quieran hacer esto, aquellos que sean jóvenes y tengan oportunidad, recuerden, la ciencia, la física y la matemática es lo que domina todo esto. Si quieren estar en algo, en el futuro, de lo que es el mundo espacial, de trabajar en algo de esto, de vivir, ese es el camino, el estudio, no hay otro, no queda y solo acá hay lugar para los mejores. O sea, para trabajar en eso no hay segundos puestos. Es una pequeña recomendación de viejo. No me siento viejo. No me siento viejo, pero es así. Es lo que sucede. Esta gente que está acá trabajando no es que sean solo unos monstruos. Se han dedicado muchísimo al estudio y a la ciencia. Es la única manera.
Well, you heard from the Advanced Space Engineers. Now you're seeing them live. This is at Advanced Space Headquarters in Colorado, where
25 kilos pesa la carga. No precisan más de 25 kilos. Es brutal. Es un microondas doméstico. Es el mismo, tiene el mismo tamaño de un microondas doméstico. ¿No? La tecnología electrónica también ha permitido reducir todos estos equipos, miniaturizarlos y colocarlos en espacios muy pequeños y sobre todo con un consumo mínimo de energía. Eso también es lo fundamental. Es chico, es liviano y no consume energía. Entonces todo el paquete cierra. Esto pasaba hace una hora. Miren lo que es el cohete. No existe esto. Los motores Rutherford tienen 9 motores impresos 3D. La compañía Rocket Lab imprime un motor por día. Estamos a T-menos 23 minutos. Asadito, ponete el enlace, por favor. Te acabo de colocar el enlace. La habilitación del enlace creo que debería de poder escribirlo.
Fuel loading of kerosene will soon begin on Electron, while additional vertical systems checks take place and the pad is evacuated. It's T-minus 3 hours now, and soon liquid oxygen will begin to flow into Electron. As the rocket slowly fills with this oxidizer,
avísame si no te habilita. Lo intentamos de nuevo.
in the air around the rocket freezes into a thin sheet of ice due to the freezing temperatures of the liquid oxygen inside. With 1 hour left to launch, it's crunch time for our operators. Vehicle cameras are switched to their launch settings. Our avionics team enables Electron for flight. Our final
Seguramente va a haber más cámaras, porque ya mostraron otra cámara de dentro.
the area is clear for launch.
Recuerden, este lanzamiento es de Nueva Zelanda, en una península, se llama Magia. Es una isla, está en el Pacífico. Es el primer sitio de lanzamiento de la compañía Rocket Lab. Tienen 2 pads de lanzamiento allí. Originalmente iban a lanzar de Wallops, Virginia, donde también están preparando el nuevo sitio de lanzamiento para el Neutron, el nuevo cohete más grande que están desarrollando. Gustavo Eitler, gracias. Dice que se entiende perfecto y susurro decidí en el panel de la órbita. Cuando llega a la órbita lunar, le lleva 6 meses de danza. Ahora vemos cuánto llega exactamente.
Well, CAPSTONE is flying on a small rocket, but it has a long journey to get to the moon. A key technology that will get CAPSTONE there is the 3rd stage of the Electron rocket called Photon. Let's head back down to New Zealand and join Muriel for more on that. Muriel?
Thank you, Daryl. So to get the spacecraft out of low Earth orbit and on a ballistic lunar transfer to the moon, for the first time Rocket Lab is using its lunar configuration of our Photon spacecraft bus. Now, unlike the Apollo lunar missions of the 1960s and 70s, which took a free return trajectory to the moon, a fuel-efficient ballistic lunar transfer
18 metros de alto, mide el cohete.
CAPSTONE on a distant orbit using a small launch vehicle. The first 9 minutes or so of the mission will follow the typical mission profile of an electron launch.
Los primeros 9 minutos son los típicos de un lanzamiento.
Stage separation, and finally end with Photon separating from electrons, second stage in an elliptical orbit. Now that is where things start to get interesting, because once separated from electron, Photon will carry out a series of orbit raising maneuvers using its Hypercurie engine, stretching its orbit into a prominent ellipse around Earth. About 6 days after launch, a final burn from the Hypercurie engine will
A los 6 días hace el último de los encendidos para la inyección.
to escape low Earth orbit and set CAPSTONE on a course for the moon.
Y ahí suelta a
The
CAPSTONE.
final burn Photon will release CAPSTONE into space for the first leg of the CubeSat Sólo flight, and then CAPSTONE's journey to NRHO is expected to take around 4 months.
4 meses le lleva luego la inserción en órbita.
CAPSTONE is expected to remain there for at least 6 months, allowing NASA to study the orbit's dynamics.
Y va a estar por lo menos 6 meses en esa órbita. En realidad la misión son 2 años.
My name is Hassan Mosley. I'm the Chief Engineer for Space Systems at Rocket Lab.
Bueno, aquí tenemos ingeniero en jefe, ingeniero de diseño.
My job is to oversee the entire technical progress of the
Él
mission.
ve el progreso técnico de la misión.
Delivery of the 12U CubeSat to its end destination.
I do mission design and flight dynamics for CAPSTONE, and I combine all that into a picture
de menos 19 minutos.
and electron are, and use that to design and optimize trajectories to get us from LC1 to putting CAPSTONE on a ballistic lunar transfer to the moon.
It's the most unique mission I've worked on at Rocket Lab so far. We've taken our Electron kick stage and turned that into a full functioning spacecraft, added a lot of delta G to its capability in order to be able to...
¿Qué hicimos? Modificamos la etapa final, la kick stage como le llaman, y la transformamos en una nave para poder llevar a CAPSTONE. Gracias, Gerardo, sí. El susurro no me molesta para nada, ni me implica ningún esfuerzo, gracias.
The way to get around that is to simply split that burn into multiple burns.
Creo que dice me alegro de ese operativo de nuevo, dice Penrod, no, creo que no dejé, digo, ni un día. Hiciste streaming del centro de tratamiento intensivo en el hospital, yo no puedo creerlo. Muchísimas gracias, desde Asturias.
Our translator injection. And the cool part about the initial phase of the mission, even though it's on day 1 of 6, is the T0 that we launch into will set our right ascension,
compartan esto en WhatsApp, en Facebook, en los grupos, en Instagram. Así sumamos más gente. Yo sé que la hora es terrible, somos muy poquitos, pero estaría buenísimo que se sume más gente.
And then 10 minutes later, we'll do our first Hypercurie maneuver, which will set the line of apsides, which is another measure of orbital alignment. So then 2 of the alignment parameters are set.
Gracias, Javier. Javier Capoche dice que puso en el Discord. Vamos a poner el enlace a Discord.
To then hit a moving target, which is the moon, kind of 3 months later.
Puso un enlace para cargar el libro, Matemáticas Simplificadas. Lo voy a cargar.
Zero pressure, deep space maneuvering to test our comm systems and our propulsion system and our cislunar navigation for other missions like Venus.
I'm really proud of the technology we developed for this mission, but I'm most proud of the fact that this technology extends to future missions for Rocket Lab and NASA, such as our Mars Escapade mission.
We are coming up soon on the go, no-go poll, one of the final gates we need to pass through.
Oh, no, viene go, no.
CAPSTONE to leave the pad for today's mission to the moon. Our talented and dedicated team have been making their way methodically through launch pad, range and vehicle preparations in the hours before liftoff. So to confirm we are proceeding all the way through to launch, let's listen in to mission control for that final go, no-go poll that will be coming up in just a few moments, and we'll keep our fingers crossed for some very good news there.
que iban a hacer el pool, o sea, el chequeo de Go No Go, pero no han mostrado más nada. Pedro dice, estoy trabajando anoche en una empresa cerca del proyecto ALMA, al norte de Chile. Aquí hay lugares muy parecidos a la Luna. Saludos. Gracias. ¿No está increíble el astronauta animado que tenemos en el rincón hacia arriba, a la izquierda?
Status go.
Avionics.
Ahí sí, Go No Go.
GNC.
GNC is go.
VMS.
VMS is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
Tank.
Tank is go.
Prop Charlie.
Prop Charlie is go.
AV Charlie.
AV Charlie is go.
Ecom.
Ecom is go.
C2.
C2 is go.
Fighter.
Fighter is go.
LD sub.
LD sub is go.
On all stations, that is the go-no-go sequence complete. We're currently T-minus 14 minutes, 8 seconds and counting. We'll go for terminal count start at T-minus 10 minutes. Be advised from this time the three-word procedure is in effect.
Bueno, todo go. Lo que hacen ahora proceden el conteo a partir del...
And there we go. That is a clear run through status checks. And as you heard, we are moving forward to the launch of the CAPSTONE mission to the moon. Our T0 launch time remains 9:55 p.m. New Zealand local time and 9:55 a.m. UTC, or 5:55 a.m. and 2:55 a.m. Eastern and Pacific. So let's go back to the Kennedy Space Center in Florida, where Daryl is with another special guest.
Thank you, Muriel. Got all the times covered. Appreciate that. Joining us now is Justin Treptow, Deputy of the Flight Opportunities and Small Spacecraft Technology Programs, to talk about how small businesses played a large role in this mission. Justin, great to have you back. You used to work here, spent 10 years here.
Yep.
You're now up at headquarters, but back in Florida for this launch.
Absolutely. I'm extraordinarily excited to be here for our lunar mission.
First question, why does NASA partner with small businesses like the ones that were involved in the CAPSTONE mission?
Well, it's an interesting interplay between government and commercial companies. With spacecraft getting smaller and more capable, we're seeing more entrants getting into the space industry. And as they get more and more experience on orbit,
se involucra, sí, con empresas pequeñas para esto. Y bueno, es lógico. Están creando nuevos mercados también.
Gathering data that we can use for other projects. This spool
Gracias, Miguel, por
have those companies turn those capabilities into services that you can buy as an organization or other parts of NASA. We heard an interview with Rocket Lab earlier talking about their Escapade mission. They developed the Lunar Photon, which is being used for another NASA mission, which would not have come to pass if it wasn't for the CAPSTONE mission. We wouldn't have the data for Gateway to take advantage of if Advanced Space wasn't here as a commercial partner on this project to bring the data from one project to another project.
That's fascinating. So you mentioned some of the benefits already that have been gained, and we've seen that through the development of CAPSTONE, right? Because NASA says, hey, go develop this, and then if there's spin-offs that are beneficial in other areas, you're starting to already see that with CAPSTONE?
Vamos a aprovechar a ver la órbita otra vez.
Some of the examples, one of the most obvious ones is with the CAPSTONE propulsion system itself.
Perfecto ver el cohete, pero la órbita que va a ser me parece fabulosa para la gente que recién se suma al canal.
Is something that is in the small sat world kind of the holy grail, being able to go somewhere and actually do something.
Los primeros 9 minutos van a ser los estándar, lo de siempre, como un lanzamiento común. Luego comienza justamente una danza alrededor de la Tierra con la acción del Sol para poder llegar a la Luna. 6 días va a estar haciendo eso, luego se suelta y luego van a estar 4 meses más para hacer la inserción definitiva en esa órbita rarísima alrededor de la Luna. La órbita esta al estar perpendicular a la Tierra, por eso le dicen rectilínea, hace que sea siempre visible desde la Tierra. Siempre que uno ve la Luna, puede ver a CAPSTONE. Miren la vuelta que hace. Yo digo cae como una pelota de básquetbol.
Rocket Lab was a very
Ser capturado por
to the launch market at that point. NASA wanted to get an opportunity to work with them.
Esto es para poder probar la órbita, calcular matemáticamente. Estación Gateway Lunar es el primer lanzamiento Artemis, el primer lanzamiento Artemis.
Best practices to the table and are able to really lead missions and projects. So it has Alana 19 and the Venture Class Launch Service.
Yo sí con esto le logro contagiar un gramo de entusiasmo en la tecnología espacial, en la ciencia, en la matemática. Soy la persona más feliz del mundo, en serio.
Partnerships with small businesses similar to this CAPSTONE mission?
Yep, so in the near future we have a number of other CubeSats that are in the work. They're also going to be doing big technology demonstrations in small packages. We have
Dice que en el futuro hay dos nuevos lanzamientos. También están preparando con otros satélites cubos.
We have a Starling constellation of small spacecraft that's going to be doing on-orbit networking demonstrations and interfacing with other commercial partners on orbit, helping to alleviate conjunctions and to make space easier to access for all participants.
Justin Treptow, thank you very much, and welcome back.
Thank you very much, Daryl.
A quick programming note before we go back down to New Zealand. I want to let you know that later this morning, Northrop Grumman's Cygnus spacecraft will be departing the International Space Station at 7:05 a.m. Eastern Time. We will have live coverage here on NASA TV starting at 6:45 a.m. Eastern Time. Again, Northrop Grumman's Cygnus spacecraft will be departing the International Space Station at 7:05 a.m. Eastern Time. All right, let's head back down to New Zealand. We are T-minus 8 minutes and counting, and Muriel Baker with the countdown.
Thank you, Daryl.
Tenemos el lanzamiento de un Falcon 9 también.
10 seconds until liftoff. You're just joining us. Welcome to Rocket Lab's Mission Control Center in Auckland, New Zealand.
Y en 5 minutos se desacopla la cápsula Cygnus, que no lo vamos a poder poner. O sea, el vídeo lo voy a subir, sí. De repente hacemos un falso vivo.
Now it is time to get you acquainted with the Electron rocket lifting off the pad today. And as you will have seen earlier,
Miguelito dice que quien propuso esta misión fue el primo, no puedo creerlo. Qué genial.
And that is because Electron is an unconventional rocket, the first of its kind in many ways, and one of the smallest orbital rockets in history to attempt to launch a spacecraft to lunar orbit. So here's a little bit more on Electron.
Claro que vamos a gritar, yo voy a gritar. J dice sí, vamos a gritar al momento del lanzamiento. Oh, bien. Miren qué divino el sitio de lanzamiento. Están haciendo su propia publicidad, pero es cierto. Dicen que es el segundo cohete más lanzado del año pasado de los Estados Unidos. Rocket Lab es el segundo lanzador de Estados Unidos. Y creo que por segundo año consecutivo. Obviamente, el primero es SpaceX. No, lanza desde Nueva Zelanda, Javier Martínez. Desde la península de Magia, en la isla. La gente que está en el sitio ya se traslada en helicóptero.
The Rutherford engine is the world's first to use an electric pump feed cycle for orbital space travel, making use of electric motors and batteries to drive its propellant pumps. It's also 3D printed using additive manufacturing processes. The Electron is also equipped with a third upper stage that serves as in-space propulsion to deploy payloads to orbit. In its most advanced form, this stage is called Photon. a spacecraft bus to support small satellite missions even beyond Earth orbit. It's to this structure that the CAPSTONE satellite is attached, ready to be carried on its way to its lunar destination in near rectilinear halo orbit.
T-minus 5 minutes and 30 seconds on the clock, and from here the launch team will move on to some of the final milestones and checks of Electron, Photon and CAPSTONE before liftoff. The mission will launch from Pad B today at Launch Complex 1, where we have 2 orbital launch pads within our private spaceport dedicated for Electron launches. Now, Rocket Lab launches typically deploy spacecrafts to orbits between 500 and 1,200 kilometers altitude above Earth's surface. But this time, as you'll know, Electron and our upper stage Photon will send the CAPSTONE spacecraft a little bit further than usual, some 1.3 million kilometers further. Around 9 minutes after Electron's second stage will separate from Photon, placing the spacecraft bus and its CAPSTONE payload into an initial low Earth orbit of just 160
Recuerden, compartan en las redes sociales, hagan clips, tienen una tijerita al video abajo que pueden tocar, agregarle el título que quieran y compartirlo como un videoclip. Es genial y ayuda mucho, en serio, no cuesta nada.
Accelerating Photon to allow it to escape low Earth orbit and set CAPSTONE on a course for the Moon. From there, CAPSTONE's journey to NRHO is expected to take around 4 months, with the CubeSat's team at Advanced Space's Mission Operations Center commanding the spacecraft to fire its thrusters to adjust its course accordingly. Now, if we are looking back at the pad camera now, we can see that the rocket's strong back has retracted and has moved into the launch position. This launch platform structure is what holds the umbilical lines, providing power to the rocket, which will fall away as Electron lifts off the pad. You can see Electron's icy white stripes on the outside of the rocket there too. Those are because of the super cold liquid oxygen propellant on the inside of the rocket, which freezes water on the outside, causing it to form those distinctive icy areas along the rocket's black carbon composite body. Now, our last weather update also confirms
Minutos, 3 minutos. Recuerden, volumen al máximo. Voy a tratar de susurrar lo menos posible. Quizás algún grito.
As we get closer to the countdown, it is worth pointing out what kind of views to expect from launch today. As always, we'll be bringing you the live views you see on your screen from various cameras at the pad and at range control. However, for this mission, we won't have the typical onboard vehicle cameras you might be familiar with for Electron launches, and that is because this mission has extensive telemetry requirements. So to reduce the load on systems and operators, we've streamlined the mission down to essential systems only. Now, while we won't have those live vehicle feeds to show you, we will be broadcasting mission data and animations so you can keep up with the launch progress throughout the ascent. And now we are coming up to a critical juncture in the lead up to launch, the switch to the countdown auto sequence. The team are tracking no issues with the launch vehicle, CAPSTONE and Photon remain healthy, and the weather is looking good. So at T-minus 2 minutes, very shortly, that autonomous flight computer on Electron will take over the launch countdown, followed by the call that LOX loading is complete on Electron. Then at T-minus 1 minute, we can expect confirmation that the vehicle's first and second stages are pressurized for launch. So, followed by that will be the iconic final countdown to liftoff at T-minus 10 seconds and engine ignition at T-minus 3 seconds. We'll hand over now to Mission Control and listen into those calls to launch.
Launch vehicle is fully on internal power. Lunar Photon is on internal power.
Ya está, es autónomo. Bueno, máximo.
LOX load complete. LOX system in recirculation.
Estamos en directo. CAPSTONE, lanzamiento lunar. Primera misión de Artemis a la Luna. Rocket Lab, desde Nueva Zelanda. Lanzamiento increíble, cohete 18 metros de altura. De menos 1 minuto, contando ya.
All helium anti-gathering disabled.
Suspenso.
Stage 1 and Stage 2 are pressed.
High flow engine purge enabled.
Histórico, histórico.
Water deluge activated.
T-minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Confirm liftoff.
HVB discharge now.
Stage 1 propulsion is nominal.
Entering burnout detect mode. Telemetría, por favor. Telemetría.
Crank ship run 1.
Por favor, la telemetría. Lanza. Ahora sí, bien.
At T plus 1 minute and Electron is in the air and onward to the moon for the CAPSTONE mission. That rocket is soaring through this nighttime sky, now past 14 kilometers in altitude in these past few moments. Now things look to be continuing nominally, which means that shortly Electron will come up against max Q, or maximum dynamic pressure. Now this is the moment when Electron will experience its most amount of mechanical stress as it travels through the atmosphere. And I can confirm from mission control that we have had max Q confirmed, so that was a successful pass through that milestone, and Electron is onward to low Earth orbit. So propulsion appears nominal on that first stage, and the Photon lunar upper stage and CAPSTONE spacecraft remain healthy inside the rocket's fairings. We are coming up soon on 3 events in the launch timeline that will occur in very short succession. So soon, the 9 Rutherford engines powering Electron right now will diminish their power and then shut off completely. That command is signaled by the rocket's flight computer and then called across mission control comms as MECO, or main engine cutoff. Now, once that action is complete, Electron will separate its first and second stages. The main booster will continue to slow and remain behind the second stage on the mission with the ignition of its single Rutherford engine. And we have had MECO.
Esto es lo que va a suceder ahora. Acaban de apagar en este momento, confirmado. Y separación es lo que viene.
We have had MECO and second stage separation, and it's carrying on now, as you can see in that animation. So soon we will be coming up to the fairing separation of this mission. That is the jettison of the fairing halves, or the rocket's nose cone that sits on top of the second stage. So now that Electron is well past the Kármán line, we don't need that fairing. It served its purpose to protect the payload and the Photon upper stage during the launch through Earth's atmosphere. So again, that fairing will separate shortly in preparation for the final stage separation between the second stage and Photon. So there we go, we heard it on comms. We have had fairing separation on that second stage, and so there's confirmation that mission is continuing as it should, with CAPSTONE and the Photon lunar upper stage now exposed to space.
Otra misión expuesta, la de NASA y la de Rocket Lab, hay una pequeña diferencia.
Now, it's very exciting to see this mission up and in the air. And if you have just joined us, we have had a great start to today's journey to the moon. We have successfully cleared the pad at Launch Complex 1 just a few moments ago, and we are now well on our way to space, having completed that first successful pass through max Q, main engine cutoff, stage separation, and fairing jettison to reach this point now in the mission. Now, Electron's second stage remains attached to the Photon lunar upper stage carrying CAPSTONE, providing it with that assist to the mission's parking orbit at 165 kilometers above Earth. The rocket's second stage is moving along nicely on its
Oh,
continued
ese
descent.
tu
Now
grito fue como el de Chewbacca.
at a very fast speed of more than 9,000 kilometers an hour.
Esto es
Soon,
histórico,
the
gente.
second stage on the Electron rocket, which is powered by our vacuum-optimized Rutherford engine, soon the batteries on that engine will need to be swapped out. Now, this is a unique aspect of our 3D printed engine.
Esto es algo que realmente es histórico. Es el primer paso de la vuelta a la Luna de la NASA. Claro, hay otras empresas en el mundo. Están los chinos, están los rusos, está la agencia europea que es socia de esto, está la canadiense, la japonesa. Pero esto es realmente el primer paso tangible de que van a poner una estación lunar. ¿Será fácil? ¿Lo harán en el 2030? No lo sé, pero esto marca un punto en la historia de la exploración lunar, no me cabe duda. Todavía falta, no te vayas, no te vayas. Tu dice ha sido maravilloso, gracias Dani por madrugar y el esfuerzo.
Stage 2 is starting to throttle down.
La misión total de la parte del lanzamiento es la estándar. Son 9 minutos. Luego de eso, va a estar una semana haciendo encendidos. Cada vez que pasa cerca de un punto en la Tierra, va a empezar a alejarse para cambiar esa órbita y hacerla cada vez más estirada para que la capture la gravedad del Sol y la empuje hacia la Luna. Es verdad.
Sitting at a nice and warm 8 degrees in temperature, and that is very warm compared to the liquid oxygen temperature, our other propellant. So that is sitting at a nice and chilly minus 178 degrees with 40% or so propellant left.
Hot swap.
And there we have the call that battery hot swap on the second stage was successful. Now, next we should expect to hear one of our operators in mission.
Es otro paso importantísimo. Es un peso muy grande. Esa batería en la segunda etapa. Eso la libera de peso. Esa batería se usó para propulsar las turbobombas de la primera etapa, que son eléctricas. Entonces ahora está trabajando con una segunda batería. Este también otro paso realmente crítico. Lanzamiento.
As this stage separation places the Photon lunar upper stage in an elliptical orbit of Earth first. Now, a reminder that 165 low Earth
Bueno, y en cuestión de 2 minutos se viene la separación de lo que es esta segunda etapa con lo que le llaman la etapa de kick stage, la etapa final, que es donde realmente va CAPSTONE, que está parte delante. Es una especie de flor. Bueno, esa etapa es la que va ahora después de esto. Hacer ese trabajo de una semana para inyectarlo en la trayectoria lunar. Cada vez que pasa por la Tierra, hace un encendido, un encendido, un encendido para ir agrandando esa órbita. Luego que completen esta fase, vamos a ver, como siempre, hacemos una repetición. Alfredo, bueno, muchísimas gracias por estar, gracias por los saludos, gracias por el apoyo, gracias a todos, a los suscriptores, a los que no, a los que escriben, a los que nos mandan mensajes. Leo absolutamente todos los mensajes en todas las redes. Estén seguros que sí, que los leo. Trato de responder la mayor cantidad posible, pero los leo. Y el apoyo que estoy recibiendo y que he recibido, sinceramente, es realmente increíble. Es reconfortante saber que están allá del otro lado también apoyando. Brito María, si sabe algo del cohete Astra que falló, no han comunicado nada, por lo menos que yo sepa.
Seeker confirmed.
Confirmado. Ahí está. confirmado. Kickstage con CAPSTONE adelante.
So with the Rutherford engine cooling down, that tells us that second engine cutoff was successful on Electron's second stage. And the Photon lunar upper stage has now departed into its low Earth orbit with the moon-bound CAPSTONE spacecraft on board.
Ahora está
As a
en
reminder,
órbita baja terrestre.
Photon
Ya
is
está
in
en
charge of
órbita
missions.
baja terrestre.
With its relightable hypercurie engine, Photon will begin maneuvering into a parking orbit just above substantial atmospheric drag, but below the Van Allen radiation belts. It is the perfect, stable platform from which to prepare for lunar departure. Now, once Photon is in the correct orbital alignment, the hypercurie engine will ignite again, performing a burn to lift the highest point of Photon's orbit, the apogee. Now, as it gains altitude and also loses velocity, and so what goes up comes back down as Earth's gravity pulls it back towards the planet. When it reaches the lowest point, or perigee, once again Photon's hypercurie engine ignites to increase velocity and raise its apogee higher. So if you've ever been on a swing set, swung to the top,
está explicando justamente lo que decíamos de cómo hacer la inserción en órbita.
On the next swing, then you've followed similar principles to what our
Lo vamos a poner. Voy a aprovechar a ponerlo aunque sea chiquito
now,
acá.
as these phasing orbits get bigger, they take longer to complete. The first will only take around 90 minutes, while the last one will take around 15 hours. Then on the final phasing pass, Photon will ignite hypercurie for a precision translunar injection burn, accelerating the upper stage and CAPSTONE to a top speed of nearly 11 kilometers per second, fast enough to break free of low Earth orbit on its way to the moon. The speed Photon is
Sí, ahora
traveling
comienza el baile de órbitas gravitacionales. Esto es lo que pasó y esto es lo que empieza a pasar ahora. Empiezan a hacer un encendido para agrandar el bujeo. Esto es lo que pasa. Y luego el Sol captura
And so with those first few hypercurie burns scheduled in the coming hours, I'm going to send it back to Daryl and the team at the Kennedy Space Center. Daryl, I know you weren't here in person, but how was that for you guys over at KSC? My heart is still pounding. I know our team is thrilled at the successful first phase of this mission.
Oh, absolutely, Muriel. Wish I could have been there to watch it with you. And boy, what a beautiful picture from here. And congratulations so far on the success of the launch. Obviously, a lot more steps to go before CAPSTONE gets into its orbit, but looking good so far with a great beginning. Quick note on this rocket right behind me, the Space Launch System, NASA's Mega Moon rocket. It completed its wet dress rehearsal. It will be returning to the vehicle assembly building in just a matter of days. It's going back on Friday. Repaired to the hydrogen leak will be made, and then the next time it rolls back up to the pad right there,
el viernes este cohete,
ready
el
to
mega
go to the moon.
cohete,
And what a
Artemis
beautiful
1,
shot
va a
we see there. We are at daybreak here on the east coast of Florida. 6
Vamos a preparar.
Identification disabled.
Estamos con el replay. Repetición del lanzamiento. Ahora sí, ni se me oye. Puede ser porque de repente estaba muy fuerte el volumen. La repetición en realidad. 45 segundos. Volumen al máximo.
High flow engine purge enabled.
Moto Spray, muchas
I want
gracias.
to tell you activated.
T-minus 20 seconds.
Diez,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Confirm liftoff.
HVB discharge now.
Stage 1 propulsion is nominal.
Entering burnout detect mode.
Dice el telefónico es un problema, sí, es un problema realmente.
Crank ship run 1.
At T+1 minutes in.
2 more Venture class launch, service class launches.
Yo no sé cuánto va a durar esto.
Both with providers that NASA has not flown with before. One with Relativity and also one with Firefly. Those will one launch from the Cape and one launch from Vandenberg Air Force Base. And then we have 2 end-to-end missions coming up as well from the West Coast. One is the JPSS-2 mission for our NOAA partners, Polar Earth Observation Satellite, and then we also have SWAT, which is a oceanography payload that's done jointly with CNES. So that's
Nunca dice curioso efecto óptico que se vio, sí, claro, el lente de la cámara. Lleno y luz. Ese lente está con el iris muy abierto y produce ese tipo de reflejos. En inglés se le llama flare.
Thank you for your time, and sorry about the rough start in New Zealand, but the new suit looks good on you, but that launch looks even better.
Absolutely. I appreciate it.
All right, thank you, Bradley. And that concludes our live coverage of the launch of CAPSTONE spacecraft. Over the next 6 days, Photon's engines will periodically ignite, and they will basically accelerate
de lo que decíamos, los próximos días va a seguir haciendo de los encendidos para acercarse a la órbita. Vamos a ver si podemos encontrar algo para actualizar y dejar puesto en el canal. Quiero agradecerle a todos el apoyo enorme que sigo recibiendo. La verdad, son increíbles.
That will take you to our Capstone blog, where you can also find NASA's Eyes on the Solar System. This is an interactive real-time 3D data visualization where you can virtually ride along with the CubeSat. Cool. We'll have that ready in about a week. And while you're capturing...
Voy a buscar ese tag, a ver qué me da. Lo detuve para que no se me vaya. Voy a escanear la pantalla. Estoy con el celu.
That QR code, I want to do one thing. I want to boop this rocket. Boop. Always wanted to do that. A special thank you to all of our guests on the show, as well as NASA's Space Technology Mission Directorate.
Wow, genial. Genial. Te lleva al sitio de NASA, donde está toda la información. Está muy bueno, se pasaron, me encantó eso.
We leave you now with a replay of the CAPSTONE launch from New Zealand and remind you to keep looking up.
Wow. Muchísimas gracias por el apoyo. Nos vemos esta tarde. Lanzamiento de Rocket Lab de SpaceX. Creo que es Starlink. A ver, vamos a confirmarlo. No, un satélite de comunicaciones para Luxemburgo. Hoy, esta tarde, a las 6 horas local Uruguay. O sea que son a las 10 de la noche UTC, 10:00 UTC. Empiezo media hora antes, como siempre. Nos vemos entonces esta noche. Un abrazo enorme. Me teletransporto. No desayuné, estoy sin desayunar. Vamos a ver si desayuno. Un abrazo, muchísimas gracias.